here?
Like, I did not realize that you could do that. Like, in the first part, where you did the natural log of the whole thing of y minus 2, I just didn't think you were allowed to do that.
You mean like right here?
Yeah. I guess, like, I understand that you can do it. It
Okay.
just didn't occur to me that that was an option.
Okay. All right. Well, I mean, I guess that's good to know, but and that's kind of the thing that that we were talking about here is that we want you guys to try these, and then like now AJ, you realize like, hey, I guess I didn't know that, and so now when that shows up in a question next week or the following week or something like that, then you're like, oh, okay, we've seen this, I know how to do it, and then when it shows up on your test, then it shouldn't be a huge deal. So that's kind of the goal of this, and especially now, where you're like, where you're just trying these on your own and then you're submitting them. All right, so I'm going to talk through this in a little bit more detail. All right. All right, so consider the differential equation dy dx equals y minus 2 x squared plus 1. So find y equals g of x, the particular solution to the given differential equation when g of 0 equals 5. All right, so this is a classic question. If I had to guess, and usually I do try to guess, this is definitely going to be a question on everyone's version of the AP test that you're going to see. Solving a separable differential equation. So this is definitely one that you have to make sure that you understand how to do. So we separate the variables. So we divide by y minus 2, we multiply by dx. We get here, we're going to integrate. Now I did show the u substitution, even though it wasn't, it didn't actually change anything. But the problem would be is if like this was like dy over 2 minus y, then you would have to do a u substitution, and u would equal 2 minus y, and du would equal negative dy. And so then you'd actually have to put a negative on the outside. And so that is something that could trip people up, as they're doing a problem like this. All right. And so we integrate, we get natural log of the absolute value y minus 2, x cubed over 3 plus x plus c. All right. And then we want to solve for the value of c. And we use the initial condition that g of 0 equals 5. All right, and so we plug 0 in, plug 5 in, and we get that c is the natural log of 3. Remember, the absolute value drops away because 3 is already a positive number. All right, then once we do that, you do have to do the algebra to solve for y. So we solve for y, we exponentiate both sides. Now, I did show how to simplify this to get 3e to the x cubed over 3 plus x, but if you were to leave it like that, it would be, sorry, I got to move that up. If you were to leave it like this, it would be just fine. And then you obviously have to get rid of the absolute values. So you do that by putting a plus or minus on each side, and then you add 2. So we get this 2 plus or minus 3e to the x cubed over 3 plus x. And then you got to realize that you can't give the answer with both the plus and the minus. You can only give one of those answers. So you have to realize, based upon the initial condition, that g of 0 is 5. So when I plug in 0, I have to get 5. So if I do x equals 0, 0 cubed over 3 plus 0 is 0. So e to the 0 is 1. So 2 plus 3 times 1, and not 2 minus 3 times 1. All right, so that's part A. And so like I said, that is a very important question. If you look at the rubric that we made available today, you'll realize that this question is worth 5 points. All right, any follow-up? Anything with part A?
So if you didn't do the absolute value of y minus 2, would it be wrong then?
If you just had parentheses there?
Yeah, like in this situation, it worked out, but like,
yes.
So like, would it still be right?
No, you would probably lose a point because the integral of the like 1 over y minus 2 is the natural log of the absolute value y minus 2. And so AP wouldn't give you credit there because you have that step technically wrong, but then you have everything else correct. So you would be likely, according to the rubric, which I'm just pulling up, you would be likely to get a 4 out of 5 on that.
Okay.
Okay. Any other follow-ups with part A?
I've got a question regarding solving for y.
Sure.
So after you integrate and you get ln of the absolute value of y minus 2, can you just isolate y and then solve for y using substitution, or solve for c using the substitution with the information given to you?
Well, okay, so you want to like exponentiate and then get rid of the absolute value and then add 2.
Yeah.
Okay, so you can do that, but what you're actually doing is you're bringing more stuff to C, right? And if you're trying to solve for C, you don't want to bring more stuff over there, right? So I
Yeah.
would always, my preference is always to solve for C at this step. Never solve for Y initially. Solve for, get the value of C and then solve for Y.
Can you
All right,
show the
thank you.
answer again?
Can I show what?
The answer.
Oh, sure.
Another question: how did you get that e to the x to x cubed divided by 3 plus x plus ln 3 is equal to x to e x cubed divided by 3 plus x times e to the ln 3 power?
Okay, so how did I go from here to here?
No, to the right of the previous.
Oh, like, okay, so here to here. All right,
Yeah.
so if I have like x to the 5th power, right? You know that 5 is 2 plus 3, right? So I could say x to the 2 plus 3, right?
Mhm.
And really, if I have x to the 2 plus 3, isn't that really x squared times x cubed?
Yeah.
And so when I have like e to the x cubed plus x plus natural log of 3, I can say, okay, well, it's e to this first thing times e to the second thing.
Oh, I
You
see.
have to
Thank
do
you.
that?
Because when I have these two things multiplied with the same base, I would add their powers together.
Oh, I see.
Now, like
Is
I
it
said, it's
don't have to
it's technically not necessary, but it's a little easier to see how this ends up being 5. Luca has a question. Would I lose points if I forgot the plus from? Oh, that was an earlier question, right? Oh, okay. So you're saying that you, Luca's saying that you went from the absolute value and you just had the plus and you never showed the minus? Okay. At that point, I think you probably would get that, but you also run the risk that if it's going to be the minus, like, did you know that you only wanted the plus and you just like kind of skipped the step? You didn't show that? Okay. Yeah, I think that's one. I think that's one that they would probably let you go with. But then if you didn't know it, then you would have run the risk of not getting the point because it would have been a minus. All right, so that's part A. Can I move on to B? Anybody else, anything with part A? Okay, let's move on to B then. All right, B says, for the particular solution, y equals g of x found in part A, find the limit as x approaches negative infinity. This one is pretty straightforward. You're just plugging negative infinity in, okay? And so we have this 2 plus 3e to the x cubed over 3 plus x, and we plug negative infinity in. So we do that, and then we get down to here, and we realize we have e to the negative infinity, but e to the negative infinity is 1 over e to the infinity, which approaches 0. And so you have 2 plus 3 times 0, so you end up with just 2. And that is just a 1-point question. According to the rubric, and there's really no work to do there. There's no points for work. If you just write 2, you get your answer. Obviously, people always ask, like, well, what if I get part A wrong? Am I still getting credit if I do it correctly using my wrong answer from part A? And the answer is obviously yes. If you have, let's say, like your answer from part A was, I don't know, let's say you like didn't have the 2 for some reason. Let's just say you had 3e to that, and then you just gave an answer of 0, then that would be correct. Okay? All right, that's B. Anything else with B?
How does the negative infinity evaluate to 0?
How does, okay, so remember, this is e to the negative infinity, right? And so like on the side, like let's say I have like x to the negative second. What does x to the negative second mean? It means 1 over x to the second, right? So if I have e to the negative infinity, that means 1 over e to the infinity. So if I do e to the infinity, that in and of itself is infinity. And 1 over infinity, remember, finite number over an infinite number in a limit problem is 0.
All right, thank you.
Okay. Anything else with part B? Okay. Let's move on to part C. All right. So part C says, let y equals f of x be the particular solution to the given differential equation with the initial condition f of 1 is 3. Find the value of d squared y dx squared at the point 1, 3. Is the graph of y equals f of x concave up or concave down at the point 1, 3? All right, so first of all, we need to find the second derivative of y. So remember, we're given dy dx, and so we're going to find the derivative of dy dx with respect to x. So we do that by using the product rule. So I take y minus 2 times the derivative of x squared plus 1, which is 2x, plus x squared plus 1 times the derivative of y, remember, which is dy dx. Okay, and so now I want to plug in 1 and 3. 1 for x, 3 for y. So I get 3 minus 2 times 2 times 1, plus 1 squared plus 1 times, where does this 2 come from? Remember, it's the value of dy dx at 1, 3. So then over here, I figured out the value of dy dx at 1, 3, which is 3 minus 2 times 1 squared plus 1, which is 2. So then I put 2 in for dy dx. And then I simplify, and I got 6. Now, technically, I don't need to simplify. I just need to realize that that thing is positive to answer the next part of the question. So remember, the last part of the question says, is y equals f of x concave up or concave down? And so remember, concave up means that the second derivative is positive. And so y equals f of x is concave up at 1, 3 because d squared y dx squared is greater than 0 at 1, 3. Remember, our answer was 6.
I'm
Okay.
kind of lost. Where did you get? Oh, okay. So you already have dy dx. So you're not using any of the stuff that you already calculated. This is
No,
like a
because
whole
it's a new function. Remember earlier it was like y equals g of x. Now it's y equals f of x. So the only thing that they have in common is that they have the same dy dx, the same derivative. Does that make
Isn't
sense?
d squared y dx squared just the second, isn't it just the derivative of dx dy though?
It's d, so remember, d squared y dx squared is the derivative with respect to x of dy dx. So all we're
All right.
saying is just take the derivative of this given equation.
All right.
Okay? Any other follow-up questions?
Where
for
did you
part C?
get? How do you know that it's equal to 2?
How do I know? This right here. That part
No, before.
up here,
Like 2 lines up.
right here.
Yeah.
All right. So I know that I want the value of dy dx at 1, 3 because I need to plug it in down here, right? And so dy dx, remember, is y minus 2 times x squared plus
Oh,
1.
you just solved it.
So I just put in y equals 3 and x equals 1. All right. Anything else with part C? All right, and remember part C is a 3-point question. So remember, we've got 5 points for A, 1 point for B, and 3 points for C.
Wait, is it okay? Because I took like the integral and then I took the derivative of it twice, which is like a lot more work, but I still got like the right answer. Would that?
Yeah, I mean, I guess that would work. It's just overkill. Yeah. Yeah, it's just extra work. And another thing, I mean, we talked about this earlier this week, and I'm going to continue to talk about it next week and the following week and the following week, is that we are going to try to minimize the amount of work that you're, that you're going to do. We want to make sure that you're not doing work that is unnecessary, and then, risking running out of time on these questions. Because remember, the time frame is short. We only have 45 minutes. 25 minutes for one of the questions and 15 minutes for the other question, and then the 5 minutes of uploading time. So we really don't have a ton of time, and we don't want you to waste any time if at all possible. All right. Anything else with 3C?
I don't know if you said this already, but do you have to say that it's continuous? Because I saw that in the answer sheet.
Do we have to say that it is continuous? Let's see. Is it concave up or concave down? Well, I don't think so. I mean, I know it does say, let's see, it says d squared y dx squared is greater than 0 and d squared y dx squared is continuous. The graph of y equals f of x is concave up at this point. Divus, you want to chime in there?
My only thought is that they're telling you that it's continuous solely so that you know that you can take the differential, or so that you know that it's differentiable at that point.
That the first derivative is differentiable at that point.
Yeah.
Yeah, that's what it seems like to me. You were told, yeah, in order for well, I guess that would be a point of inflection that I was thinking of. The fact that that function is defined there, I think is enough. I don't think they're going to take off if you don't state that it's continuous. Okay. All right. Anything else with 3C? All right, let's go ahead and move on to number 4 then. All right. 4. All right. All right, so we're given this graph. All right, so it says the function f is defined on the interval -5 to c, where c is greater than 0 and f of c equals 0. The graph of f, which consists of 3 line segments and a quarter circle with center -3, 0, and radius 2, is shown in the figure above. All right, part A. Pretty simple part A. Find the average rate of change of f over the interval -5 to 0. Show the computations that lead to your answer. So remember, average rate of change is just slope of the secant line. So we're just doing y value minus y value over x minus x, right? So f of 0 minus f of -5 over 0 minus -5, and I get 2/5. Any questions on that one? No questions on that? That was pretty straightforward part. And just to note there, that part is only worth 1 point, I believe, right? 1 point just for having 2/5, but it does say show the computations that lead to your answer. So if you just wrote 2/5, the way that I read it is that you're not going to get that point, even though it seems trivial. It does say show the work, so then you should probably show the work. All right, I'm going to move on to part B then, if there's no questions. All right, so part B says, for x between -5 and c, let g be the differentiable function given by g of x equals the definite integral from -1 to x of f of t dt. Find the x coordinate of each point of inflection on the graph of g. Justify your answer. All right, so you're given g of x equals the definite integral from -1 to x of f of t dt. All right, so then you have to realize that a point of inflection on g means that g double prime changes sign. And so you have to realize, according to the second fundamental theorem of calculus from section 7.4, that g prime is equal to f of x, right? So remember, if I have g given here, how do we find g prime? We take x and we put it in for t and multiply by the derivative of x, right? And so g prime equals f of x, which means g double prime is f prime. And so very simple, that means that g double prime is the slope of this graph. So really the question is simply, when does the slope of this graph change signs? So remember, this graph has a negative slope, positive slope, negative slope. So it changes at this point at x equals -3 and at this point at x equals 0. And so you would say g has a point of inflection at x equals -3 and 0 because g double prime, which is f prime, changes signs. Any questions on part B? Okay. Once again, part B is pretty straightforward question that you're probably going to see something very similar to. So certainly worth, making sure you understand. All right. And on that particular question, that is worth 3 points. Okay, 1 point for giving that g prime is equal to f, 1 for identifying x equals -3 and x equals 0 as the answers, and then your justification. So something about the fact that g double prime, which is f prime, changes signs. Okay. All right, can I move on to part C then? All right, so part C. Find the value of C for which the average value of f over the interval -5 to c is equal to 1/2. All right, and so we have to remember the average value formula. All right, so remember the average value of, let's just say like average value of f on the interval a to b, which is how we gave it when we did this section, is 1 over b minus a times the integral from a to b of f of x dx, right? That's how we gave it. And so if we want the average value of f over the interval -5 to c, then we do 1 over c minus -5 times the definite integral from -5 to c of f of t dt. And you were told that that average value is 1/2. So you have an equation here, all right? And now sometimes people get confused about this equation, but remember, once you integrate f and you plug in -5 and c, right, then really you just have an equation and the only variable in it is c, all right? So now how did I get this stuff? Remember that the integral of f from -5 to c represents the area under this curve from -5 to c. And so I've got 4 regions that I discuss. I have this quarter circle region, which is below the x-axis. I have this triangle, which is below the x-axis. I have this triangle over here on the left, which is above the x-axis, and this triangle, which is above the x-axis, all right? And so I found the area of this quarter circle, which is 1/4 of pi times 2 squared, because the radius is 2, all right? Then I have this triangle, which is below the x-axis, so that's why it's negative, just like that one over there, is 1/2 of the base times the height. The base is 1, the height is 2, so 1/2 of 1 times 2. All right, then I have this triangle here, which is a 2 by 2 right triangle, so 1/2 of 2 times 2. Notice this is positive because it's above the x-axis. And then this last triangle here, it's a triangle once again, so it's 1/2 of the base. The base is c, right, from 0 to c, and the height is 2, so 1/2 of c times 2. So then I take these 4 areas and I put them here instead of that integral, because that's what the area under the curve is, and I just simplified those, all right? And so now I need to solve for c, so this is some, relatively simple algebra. I multiply by c plus 5, I distribute, and then I group together the stuff with c, the stuff without c, and then I solve, and I got 3 plus 2 pi.
For
Any
this
questions,
question,
AJ?
yeah, for this question in the rubric, it writes, I guess you do have to have that, huh? It says you have to write the integral and then you have to do it separately. You have to write both of those down to get the points.
Well, okay, so so they're not super clear here. It says, so the integral, the equation, and then the answer. So the fact is that you're writing the integral, right? So you recognize the value of the average value, right? And then you're setting it. So now, like, if you wrote just this top part, are you going to get 2 points? I don't believe you are. I believe that the equation piece is when they go down here and you're equating whatever this thing is on the left to 1/2. And then obviously solving. Does that clear that up? All right. Anything else with part C? Okay. All right, so let's move on to D then. D says, assume that C is greater than 3. So in my picture, I just put 3 somewhere here, right? Because C is greater than it. All right, the function h is defined by h of x equals f of x over 2. Find h prime of 6 in terms of C. So h of x is f of x over 2, and so we want h prime of 6. So we're going to take the derivative, right? So derivative, according to the chain rule, we're going to take f prime of x over 2, and then times the derivative of x over 2, which is 1/2. All right, and so then I'm going to evaluate f prime of 6 over 2 times 1/2, and remember 6 over 2 is 3, so f prime of 3. So remember, because you were told that C is greater than 3, 3 is on this line somewhere, right? And so I want f prime of 3, so that's very simple, just the slope of that line, right? And so the slope of that line, remember, if we're starting here at 0, 2, and we're going to C 0, the slope is -2 over C. And so instead of f prime of 3, I put -2 over C times 1/2, so obviously the 2's reduce, and I'm left with that h prime of 6 is -1 over C. All right, any questions with part D?
So f prime of 3 is just the slope of the line at 3.
Correct.
All right.
Okay, anything else with D? Okay, and if you want additional explanation, or you want to hear it again or whatever, obviously we're recording this, but then we also have the solution videos that we did and posted on Schoology, so you can go ahead and access those videos at some point. And if you want further, you can always email me or Mr. Divas, and we can try to help you out. But we're going to have additional FRQs to practice next week. And so it's kind of an ongoing thing. So really, we're looking at, today is, what is it, the 9th, right? And so we still have a month of practice where we can, give you a whole variety of different problems that we expect to see parts of on the AP test. So I would say, for you guys, just keep trying every day, and then show up or view videos or view rubrics or whatever, and try to gain your best understanding of it. And if you do that over the next month, I think you're definitely going to be in a good place when it comes time to take that test. All right, any other follow-up questions?
Will Mr. Davis ever do a video?
Sure,
Maybe.
it's okay. I mean, AJ, it's okay. I get that you like him more than me. I'm over it.
It's definitely not the case. That is definitely not the case.
You'd be surprised. I'm not very nice to either of you.
Oh, well, at least you're consistent.
I mean, I'm used to people not being nice to me. I have teenage daughters, and so I'm over it. All right. If anyone else has any other questions, we're happy to answer them. Otherwise, nothing else for this class this weekend, and we'll have some more FRQs out there for you guys on Monday.
Thank you.
All right. Have a good weekend.